Hi there, everyone, and welcome to this session on working with tin surfaces within BricsCAD V24. Before I hand over to Rick, let me explain that this is a 3-in-1 session. First, we're going to look at tin surfaces created from survey points and break line data, and there's a sprinkling of our super duper new label tools in there as well. Then we'll talk about our great new tools for creating tin surfaces from contour data. Finally, after that, we'll talk about creating tin surfaces from point cloud data. Now, to hop to the part of the session you're most interested in, simply hop forward and back using the bookmarks, or use your time slider to hop to these timestamps. Now that we know what's going on, let's get started. We know the tin surface is the foundation of most civil engineering and surveying projects. BricsCAD can create and edit a tin surface from any 3D data with high-performance tools and efficient workflows, which are easy to learn. And you can continue to use this tin in BricsCAD or export it to LandXML to deliver to clients, regardless of which civil design software they use. Now, as well as enhancements to the tin surface user interface to make it easier to learn and faster to use, we've improved the tools for working with survey points, break lines. There are improved tools for creating surfaces from contour data and improved tools for creating surfaces from point clouds. So with that, I'll hand it over to Rick.
Building a tin surface from any type of 3D data is fast and efficient in BricsCAD. In this example, we're going to build our surface from traditional survey data. This drawing already contains a set of survey points that has been imported. And I can zoom in and look at any of these points. I can also see in the Civil Explorer that I have a point group already created called Topo. If I right-click on that and pick Select, it'll select all the points that are in that point group, and these are just the points that I want to use to build a surface. I'll escape to deselect those, go to Tin Surfaces in the Civil Explorer, and pick Create. Instead of just selecting these points from the screen where it would treat them as CAD objects, instead, I'm going to select the option at the command line to create from a point group. The point group name I want to use is Topo, and it immediately builds the tin surface for me. In the Civil Explorer, I can expand tin surfaces, and I see that I've got a surface called Surface 1. On the General tab at the bottom, I could rename this and call it EG or Existing Ground or anything I would like. And I can go to the Definition tab and see that we added points from a point group and that it also removed outer edges. I can just double-click on Remove Outer Edges, and here I could use a maximum edge length. This maximum edge length only looks at exterior triangles. It does not remove any triangles that are interior to the surface, so it won't create any holes or voids. My maximum edge length, I'm going to try 50 feet, which was way too large. Almost the entire surface disappears. If we go to 100, we can see it comes back slowly. 200, at that point, looks pretty good. I've cleaned up the edges where I don't want triangles extending outside of the limits of the data that I created. We could have also done this by using a surface boundary or deleting tin lines. But this is a quick, easy way to go in and analyze the entire surface and essentially shrink wrap it. I'll close out of that surface definition. We'd like to add break lines to this surface. However, the break lines have not been drawn. So I'm going to go to my layers and set my break line layer current. and I'll just draw a 3D polyline. So I'll run the 3D polyline command, and I could snap to all of these different locations if I wanted to. Or as I zoom in, I can see I want to connect from point 1408 to the other end of this driveway, which is 1447. If I use one of the new transparent commands for point number, it changes my prompt and I can just enter the point number with a range. So 1408-1447. I'll enter and it draws that new 3D polyline for me. Enter to end the command. And anytime you have sequential point numbers, it makes them very easy to connect with that. In this case, I don't want to take the time during this demo to draw all of those individual break lines. So I'm just going to erase this one and insert a block that has most of them for me. So I'll insert this block and I'll explode it, and that adds the 3D polylines for us. There should be one more break line up in this area. And to make this a little bit easier to see, I'm just going to turn off the visibility of the tin. I can toggle that off in the Civil Explorer just by clicking on the visibility button. I'll draw another 3D polyline. And this time, I'm going to use the point object transparent command. And these points that are the top of this ditch, I can select with the transparent command by picking any part of the point. I don't have to pick the symbol. I can pick on the label or anywhere else. So that makes me a quick 3D polyline representing my break line. I'll go back and turn the surface EG on so we can view it. And I'm going to change the visual style to turn off the triangles and turn on contours. Then I'll right-click on the surface EG and click Add Break Lines. I'll select all the break lines and enter. At the command line, it asks what type of break line it is, if it's standard or projected onto the surface. This is going to be a standard. And as soon as I enter to end that command and that selection, I see the tin surface update reflecting the new elevations from those break lines. Just examining the surface a little bit, I can see that I have a lot of contours in this area, probably going down to a particular hole or a bad point. And if I zoom in, I have a shot at this location that we've been told in the field notes was at the wrong elevation. So if I go to Properties for that point, just in the Standard Properties command, I can see the elevation is 414.27. I'm going to change that to 434.5. And as soon as I enter, the surface is automatically rebuilt and the contours redisplay, fixing that giant hole that we had. I also notice an area where my break line should have continued from point 1151 up to point 1152. We can edit that just with the simple polyedit command that you're probably familiar with. Type in PE for polyedit. I'll pick the polyline, edit vertex, and go to the end and pick insert vertex. I can also use those transparent commands here. So I can pick point number 1152, and it adds that new vertex at point 1152 at the proper elevation. The other thing that happened while we didn't see this on our screen is the surface was already rebuilt and the contours were updated to reflect the new break line. Next, I'd like to label some of our contours. So I'll start by going back to our layer command. I'm going to freeze the break line layer just to remove those and clean things up. I'll also freeze off the points layer, so all we see are the contours that we want to label. I'll go up to the Add Surface Labels command on the ribbon. My label type is going to be contour, and I'll just use the default styles for both the major and minor contours. I'll pick the surface, and then I'll draw a line across the surface wherever I want to label the contours. After doing that, when I zoom in and look, I can see here's the contour labels. Editing the contour label styles is improved and much easier in BricsCAD V24. I can see this by going to the Settings tab on the Civil Explorer. Under Surface Labels, I have a collection for contour, and I just currently have one label style here called Default. If I right-click on that, I can either edit or copy it. In this case, I'll edit the style. And on the General tab, we can select things like the text style, the layer it's placed on, and plan readability. On the Component tab, we can see that I have one component called Surface Elevation. I can go in and edit the component contents. Here I have options to change the units, the precision, the rounding, and even add commas for digit grouping. So here is a place that we could change the decimal precision of the contour label if you have a very flat surface and maybe you're labeling half-foot contours or every 1/10 of a foot or 1/10 of a meter or whatever you're working with. I'm going to cancel that, and back on the Component tab, I can change the color of that label. Maybe let's make it red just to be different. Click OK, and that updates not just that label, but every label that uses that particular style. Those labels are based on the annotation scale of the drawing. So if I change the annotation scale from inch 20 to inch 40, we see they all automatically scale up. If I pick that label, I can move around the line that was used to determine their location and adjust where the labels are displayed. If we wanted to add spot elevation labels, the process is very similar. I can go to Add Surface Labels. I'll do Spot Elevation, and I'll use the default style again. Pick the surface, and I'll pick a location for that label. When I zoom in on it and pick the label, if I move it around, you'll see it updates dynamically. And this is another example where we could change the label precision if we don't want to show 3 decimal places. I could go to the Settings, Spot Elevation, the default label style, edit the label style, go to the Components tab, and this time I'm going to edit the Surface Elevation component. Here I'll just update the decimal precision to 2 decimal places. Click OK. and the label automatically updates. You can see how quickly and efficiently you can build a tin surface from traditional survey data here in BricsCAD V24. In BricsCAD V24, we've added a specific surface definition type to allow us to build surfaces from contour data more accurately. We know that contour data is not the most ideal form of surface data for you to use, but that's sometimes all that you have. So in this case, we have a drawing that has just 2D polylines at their proper elevation representing our contour data. And we can see if I pick one of them that the elevation of this particular contour line is 7950. To build a surface from this, I'll go to the Civil Explorer, right-click on Tin Surfaces, pick Create. And instead of just selecting the objects, like you would if these were break lines, at the command line we have an option to create from contours. I'll use that option, and I'll select all of the polylines that represent these contours. Enter, and at the command line, it asks me if I want to use any weeding or supplementing factors. These allow us to weed out extra vertices on the polylines if they were over-digitized. And supplementing factors allow us to add in additional vertices if there just aren't enough, or if there are arcs in the contours. I'm not going to use any weeding or supplementing for these contours in this case. I'll say no. Same thing for supplementing. And it quickly goes out and builds the surface. In the Civil Explorer, if I expand Tin Surfaces, I'll see that we just created surface 1. And if I look at the definition below, I can see that it created from contour data. If I double-click on that definition value, I could go in and add any weeding or supplementing factors that I might want to use. For instance, I could turn on the weeding factor and say that any points or vertices on these contour lines that are closer together than 5 feet, in this case, with an angle between those points of less than 4 degrees, those vertices would be removed. They would not be removed from the polylines, but instead they would just be skipped when building the tin. And in this case, it really doesn't make much difference because the data was not too dense anyway. A definition is also added to automatically clean up the outer edges. We can see a number of areas in the surface where it is triangulated outside of the extents of the contour data we have. This could be cleaned up by adding a surface border or by deleting tin lines. But I can also use Remove Outer Edges, and I'll just pick a maximum edge length. And we'll do a maximum edge of 100. When I look at this, I can see that that value of 100 was too small and took out too many triangles within the surface. If I set it to 200, it cleans it up much better. And although we have a few extra triangles along the edge, this will look pretty good. If I go to the visual styles, I can turn off the triangles and turn on the contours. And this is a very steep site, so I'm going to change my major contour interval to 25 and my minor interval to 5. And we can see that in an area like this valley, our contours are following the original contour data very closely. This is because when we treat it as contour data in the tin definition, it automatically minimizes any flat triangles that it can. If we didn't do this and just treated these polylines as break lines, BricsCAD would simply triangulate points together by nearest neighbor. And what would happen is you'll see a lot of contours cutting across the end, and you would lose this bulge or the definition of that ditch or valley. If we were to create a profile along this now, it would look really good and very smooth. If we weren't able to minimize flat areas, what you would see instead of a smooth valley would be more of a stair-stepped or tiered result from the tin, which is not what we're trying to represent. Once you build the surface from contour data, you can use any of the other tin surface commands available in BricsCAD. We could label the contours, do volume calculations, target grading, or look at water drop to analyze the surface. So although contour data is not an ideal data set for you to use, if that's all you've been given for your project, we can now build a very accurate tin from this in BricsCAD Pro. With advances in scanning hardware and drones, it's become increasingly common to have very large data sets in sizes of tens of millions, hundreds of millions, or even billions of points. And it's simply not practical to use all the points in data sets of this size to build a tin surface. And common solutions, like a grid-based decimation, cause you to lose vital resolution for your data. They're not keeping the points you want, they're just simply deleting them based on a grid spacing. That's why we've been working to bring you better tools to attack this challenge in BricsCAD. We will allow you to build an optimized surface from the points you need and not from the points that you don't. Let's take a look at this in the new BricsCAD V24. I currently have a drawing open that has a point cloud attached, and BricsCAD can support many different common point cloud file formats like LAS, PNT, and even standard ASCII text files. So whether your data comes from aerial photogrammetry, LiDAR data, terrestrial scans, or even bathymetric scans, it doesn't matter. BricsCAD can work with that large data set. I currently have a point cloud attached, and we can see in BricsCAD, I can rotate that point cloud around and view it in real time. If I select the point cloud and look at it in the properties window, I can see it's about 6.4 million points. Now, this is not a large point cloud by any stretch, but it's still probably more points than we want to use to build a tin surface. Because while we might be able to build a surface from that, it would be slow and it would bog us down through the entire project every time that we do anything related to that surface, or even in panning and zooming. So let's take a look at the process to build a surface from this point cloud. I can go to the Civil Explorer, right-click on Tin Surfaces, and just pick Create. Then at the command line, I'm going to select Create from Point Cloud. I'll pick my point cloud object and return. Then BricsCAD asks me if I want to simplify this tin surface. In this case, I'll say yes, and it will ask me for a radius and an elevation difference. What it's going to do is just skip all of the points within that radius that are within that elevation tolerance. So I'll just start with a radius of 10, and I'll do an elevation difference of 0.2. BricsCAD now processes through the entire point cloud, looks at all those points, filters out the ones that fall within the criteria, and gives me a report at the command line. And I can see that I have about 82,000 points left in the surface instead of 6.4 million. I'll just quickly turn off the display of the point cloud so we can see the tin surface. And as we rotate that surface around, we can see we still have a high performance surface within BricsCAD that I can rotate real time. I can also see that surface in the Civil Explorer. If I select the surface in the Civil Explorer and go to the tin definition, I can see I have a definition of adding points from the point cloud. I can right-click on that and edit, and if I wanted to, I could go back and change that simplification radius or elevation difference. So if you don't get it right the first time, you don't have to delete and start over. You can continually modify it and you can continually modify to improve the accuracy of your surface. If we look at this particular area, we have a road and a very steep slope along the side. And while the parameters that we set allowed us to filter out points within a particular tolerance, while the parameters we set allowed us to filter out points that were within a particular tolerance inside of that specified radius, we didn't get to tell it exactly which points to keep. So you can see in some areas like this, where my cursor is, we have some larger triangles that are jumping all the way across this road. If I switch this over to plan view, and we zoom in, I can still see the problems in that area. And what we'll do next is densify the surface in that area. I'll go back to my tin definition where we added the point cloud. And I'll turn on Enable Densify. Then we'll just click Add New Area. And at the command line, it asks me what the elevation difference would be again. Now I could use the same value, or I could use an even smaller one. We could even use 0 if we want to use all the points within that area. I'm just going to use 0.1, and we have the option of applying this to the entire surface, or within an existing polyline, or we can draw a polygon. I'll just draw the polygon. And we'll go around this area. And I can see the values that I entered for this particular densification area. We can have multiple areas throughout the surface. We can have as many of these areas throughout the surface as we want. You'll notice there is a rebuild button at the bottom of this dialog box. Whereas most of the tin definitions update in real time, because you may be working with huge data sets here, we've told it to not rebuild until you tell it to. So I'll rebuild the surface. It'll go out and reprocess all that data in that particular area. And once that's done, we'll be able to see, even in plan view, the results look much better. If we rotate that around, I can see a much more accurate surface along the area where we densified. And in areas that aren't as important, or the terrain isn't as challenging, we don't need those extra points. If we look at the surface statistics, I can see that the number of points here is about 308,000. So a lot of points, but certainly not anything near the 6.4 million that we started with. We could continue to use this surface in BricsCAD for any of our other design operations, or you could export it to a land XML file and pass that off to any other program. I would just simply go to the Home tab, go to Land XML, Export, pick my surface, tell it where I want to save it, and simply save the file. This will allow you to use the optimized version of that surface in any other program that you want. Or if you keep it within BricsCAD, all of the labeling and display tools that we've looked at in the other breakout sessions will work on this surface just like any other.
Thank you, Rick, for this great session, and thank you all for joining us to see how we keep working to make our tools for working with tin surfaces better, faster, and easier. Don't forget to join our other breakout sessions for more information on our improved workflows for civil and survey users. Thanks, everybody. See you next time.